is called as a reaction mechanism. Is called as reaction mechanism. Okay. Now, in this reaction mechanism, we are going to discuss that. I am dividing this into a few categories. Number one, we shall discuss about reagent. What type of reagents are there and where they are attacking and how they are attacking. After that, we will discuss that what are the things which facilitate the attacking of these reagents, which are called electronic effects there. See, let me explain that on an organic compound, there are no site for attacking of a reagent, because for a reagent to attack on the organic compound, we need either electron deficient site or electron rich site, and these electron rich and electron deficient sites are created in the organic compound due to the electronic effects, and those electronic effects I will discuss in the next stage after discussing about the types of reagents there. Then after discussing about electronic effects there, we shall discuss what are the intermediate compounds possible to be formed, reaction intermediates, carbocations, carbon ions, carbenes, nitrines, free radicals, and so on. After that, we shall discuss in detail about the different types of organic reactions, addition reactions, substitution reactions, elimination reactions, and so on. Then we shall enter into the all types of organic compounds like hydrocarbons, alkyl halides, and so on. Okay. Now I am going to discuss that types of reagents. Types of reagents. What is a reagent? Already we have seen that reactant in organic reactions which is not supplying the carbon atom for the formation of new bonds is called as the reagent there. And the reagents can be divided into three types, and what are they? Let us see. Now, depending on their nature, these reagents are divided into three types. Remember, these reagents can be organic or inorganic, and the reagent will always attack on the substrate. The attacking species on the substrate is also called as reagent, and the reagents are divided into three categories, and these three categories are nothing but number one. These three categories are A, B, and C. The first category are called electrophiles. They are electrophiles, are called electron loving reagents. Nucleophiles. Then we have ambiphiles. You know what is the meaning of ambi? Ambi means both. Ambiphiles. Let us discuss about each in detail. That is, first one I will take up that is electrophiles. What are these electrophiles? I am going to discuss there. The name itself indicates that the philic means loving always. So these reagents are electron loving reagents there. So those reagents which are electron loving are which will attack on the high electron density carbon atoms called as electrophiles, right? The reagents which are electron loving, the reagents which are electron loving and attack on high electron density sites, right? Density sites are called electrophiles. Now, one thing question arises here, that why they are electron loving species. Very simple, that all the electrophiles are generally electron deficient species there. That is where they need extra electrons to get the stability or sometimes octet. That is why these electrophiles are acting as electron loving groups there. Okay. Now I should say that electrophiles are electron deficient. electrophiles are electron deficient. They are electron deficient. Okay, one point is clear, that is. And these electrophiles can be positively charged or they can be neutral. Two types of electrophiles are there. What are they? Positively charged electrophiles. Positively charged electrophiles. Positively charged electrophiles. Anywhere if you see the positive charge on any species there, then there is a possibility of it acting as the electrophile. Some of the examples for this that I can give you are H plus is an electrophile. H3O plus is an electrophile. Cl plus, this is chloronium. Br plus, I plus, NO2 plus, this is nitronium, nitrazonium, R plus, this is alkyl carbocation. So these are all acting as the positively charged electrophile. Some of the examples I have given there. So any species is getting the positive charge will show the tendency of acting as the electrophile. Now, there are some neutral electrophiles are also present there. Neutral electrophiles. Neutral electrophiles. This R plus, which in the previous case which I have discussed, is also called as carbocation. About this we are going to learn in the reaction intermediates later on. What is a carbocation? Is very simple. Any species carrying the positive charge on carbon atom is called carbocation. Now, similarly, in the neutral molecules, we have got BF3, boron trifluoride. We know that it is an electron deficient compound. AlCl3, very often these are used as electrophiles in organic reactions there. Zinc chloride. Then, you know what are the Grignard reagents? You have studied in your 11th class. RMgX is also called Grignard reagents. SO3 can act as a neutral electrophile. FeCl3, this is also one of the neutral nucleophile. So these are all some of the examples for the neutral electrophiles. They are acting as the electrophiles because of their electron deficiency there, right? One thing let me tell you that so that you can understand it better, that the word electrophile we are using is nothing but similar to the Lewis acids. Every Lewis acid is capable of acting as an electrophile there. So one statement can let me give you that all electrophiles, if you have any doubt about an electrophile, you can decide that whether it is capable of acting as a Lewis acid or not. If it is capable of acting as a Lewis acid, definitely it would be an electrophile. Okay, all electrophiles are Lewis acids. Remember that all electrophiles are Lewis acids. Okay, right. Now we shall discuss about the second type of reagents. They are called, that is, all electrophiles are Lewis acids. Next, let us take up the nucleophiles. Nucleophile, the second category of the reagents there. They are nucleus loving species or nucleus loving reagents there. It means that they always attack on any atom which is positively charged there. So the reagents which are nucleus loving, and attacking on electron deficient sites, electron deficient or electron deficient carbon atoms are called as nucleophiles. Okay. Now again, these nucleophiles are two types: negative nucleophiles and Neutral nucleophiles. Always nucleophiles are electron rich species. They will contain some extra electrons, or definitely they will contain at least one lone pair of electron. One point let me tell you that nucleophiles contain, this is one of the characteristic feature of all nucleophiles. Nucleophiles contain at least one lone pair of electrons. Lone pair of electrons on the central atom. One lone pair of electrons on the central atom. Okay. This is about the nucleophile, right? Now, categories of the nucleophiles I was talking about. These nucleophiles are divided into two types: negative nucleophiles and neutral nucleophiles. Negative nucleophiles. Any species which is carrying the negative charge can act as a nucleophile, because that negative charge on that species is due to the presence of minimum one lone pair of electron there. Very simple. H minus, this is called hydride ion there. Cl minus, then Br minus, I minus, then R minus, OH minus, like this, so many etc. All these species are example for negative nucleophiles. Next comes neutral nucleophiles. What are these neutral nucleophiles? These are the nucleophiles which are neutral but contain at least one lone pair of electrons there. Now you can take water. It is containing two lone pair of electrons on the oxygen. Then ammonia, there is one lone pair of electron there. Next, all amines comes under this category there, because all amines also contain